Hey guys, I'm back with a new video. In this video, let us learn about the concept of pure and impure functions. Pure and impure functions. So what is a pure function? A pure function is a function which for some given argument will always produce the same output. Same input always produces same output. So for example, if you have a multiplication function which takes two numbers 3 and 2, it will always produce the same output, which is 6, right? So the same input always produces the same output. So the same input arguments will always produce the same value as the output in case of pure functions. Now one thing you need to understand here is that anything that we have outside the function must not be changed inside a pure function. So this is also known as a side effect. So let us understand this with the help of an example. Let us go right inside Visual Studio Code, and here I have an index.html file. I have linked a script.js file, and inside the script file, let us create a pure function. So let us define a function and name it as multiply, function multiply. Let me zoom this up, and this takes on two arguments, number 1 and number 2. And inside here, let us return the result of the multiplication of these two numbers. Return number 1 times number 2, like this. Now to give this a whirl, let us invoke both the functions console.log multiply. Let us pass the arguments as 1 and 2, and console.log multiply 3 and 4. Now let us head over to the browser to see what we get. So here you can see for the first multiply invocation we got 2, so 1 times 2, and 3 times 4 gives us 12. So you can see we get the results 2 and 12 getting logged to the console. So no matter how many times you do the same invocations, these two invocations, no matter how many times you do them, you will always get the same results. So this is an example of pure function. So if we pass the values 1 and 2 to the multiply function, we'll always get the same output, which is 2, no matter how many times you invoke the function. With these exact two arguments, you will always get 2, right? So this function is a very simple example of a pure function. As you can see, it doesn't change anything outside the function. It just takes two arguments, number 1 and number 2. It multiplies them and spits out a result. And the result for this simple example is only depending on these two arguments, right? Now this was about the pure functions. Let us see an example of impure functions. So let me comment here pure functions, and down here let us say impure functions. Now let us define a function and name it as randomize. So function randomize, and this will take on a number as the argument. So let us say number 1 and a numbers array numbers. Now right inside the function, let us say math.random, so math.random, and then inside it let us apply the floor function on the number 1 that we are receiving as the argument. So math.floor number 1. So we are applying the floor operation on the number that we receive as the argument right here, and to whatever random thing we get, let us multiply it to the length of the numbers array. So numbers.length, like this, and let us return it. So let me zoom this out. Now to give this a whirl, let us first pass the number 1 to the randomize call with a value of 3, and the array of numbers as 3, 4, 5, and 6. So let me wrap this in a console.log, and here let us say first invocation, like this. Now let us duplicate this for the exact same arguments and paste it down below. Change this to second. Now to see this in action, let us give it a preview in the browser. So you can see for the exact same arguments, 3 and this array, for both the invocations we are using exactly the same arguments. For the randomize function, each time we are getting different results, right? For the first invocation we are getting 1.9 something, and for the second invocation we are getting 2.6 something. Let us again reload, and you can see each time the values are changing, right? Now the thing that you need to understand here is that there is some sort of unpredictability when we introduce the random function of the math class because it can give you any value, and because of this behavior of the random method of the math class, this term becomes unpredictable. It can have any value, but this numbers.length term is predictable, right? So for this array of 4 elements, this term will always be 4, but this is the unpredictable part, right? So this was a simple example for impure functions. So let me sum this up and write it for you. So for impure functions, so for the randomized function example, we just saw that for the same input, we get different outputs for each successive invocations, right? So this is in case of impure functions, whereas this was the case for the pure function. So if we multiply these two terms, one is unpredictable while other is predictable, then the result will always be unpredictable. So this was a simple example for impure function. Now just a while back, I mentioned that if a function doesn't change something outside the function, then it is considered to be a pure function. So function is considered impure if it changes something outside the function, meaning that it introduces side effects. Also, firing an async HTTP call from a function is also considered as a side effect. So let us do a recap of what we learned till now. First thing is that math.random, this thing, is an impure function. It changes the internal state of the math object, which means that on each successive invocations, it gives you a different value. Now let us see a couple of more examples on impure functions. Let us define an impure function to check for whether a number is even or not. So first, let us set up a boolean if even, and set this to false as the initial value. Next, let us define an impure function for checking whether the number that is passed to us is even or not. So let us name it as impure even variant. And this takes on a number as the argument. So on the number that we get, we check whether the modulo 2 of the number is 0 or not. So if number modulo 2 is 0, if it is 0, then we set is even to true. Now remember that the is even variable that we have is sitting on the root scope of the file, which is right here. I mentioned just a while back that a pure function should not change something that is present outside the function. But in this case, as you can see, we are mutating the is even boolean and we are changing its value from false to true inside this function subject to the condition number modulo 2 triple equals 0, right? And this variable is sitting outside the scope of this function, and hence this is an example of impure function. Now finally, right after the if check, let us return the is even variable at the bottom. Return is even, like this. Now to see this in action, let us do some invocations. First, let us test the function for the number 5. So console.log impure even variant and pass this a value of 5, and let us again invoke it with a value of 6 and then again with a value of 5, like this. Now let us give this a preview in the browser to see what we get. You can see the first time we got false, and then successive 2 times we are getting true. Okay, so for the first time, when it runs with a value of 5, this check got bypassed and we return false, right? Then on the second invocation, we passed a value of 6. This check runs, is even gets set to true, and hence true gets logged for the second log. Then we again pass the value of 5. Here the check gets bypassed, but remember the is even value after the second log got changed to true. So for the third invocation that we made right here, we are simply returning that true, right? So here we got false, which is definitely correct. Here we got true, and here we also got true, which is definitely not right. So for the first log, you can see we got false, which is correct because 5 is an odd number. For the first invocation, it bypassed the if check and returned us the global value of is even, which for start we set to false. And for the second invocation of the impure even variant function, for which we passed the value of 6, what happened was that it made into the if check, the number came out to be even, and the is even variable sitting on the root scope got changed to true, right? So it is here, right here, we made a mutation. We committed a side effect. We changed a variable that was sitting outside the impure even variant function, which is this variable. We changed it from within the function. But despite that, the output was correct because 6 is indeed an even number. So after the second invocation, the value for isEven variable sitting on the root scope got changed to true. So now lastly, the function runs for the number 5. It bypasses the if check and simply returns that true. But of course we know that the output for third invocation is not correct, as we know that 5 is an odd number. So the output should have been false instead of true, right? Now to fix this problem, let us define a new function that doesn't rely on this external binding and instead changes something that is present within the function. So in simple terms, let us transform the above function to a pure function so that it gives us the correct output always. So let me copy this entire code and paste it down below right here, and let us bring this line down right inside this function. Change the name to pure variant, pure even variant, and this time we are defining the isEven boolean not outside but inside the pure even variant function so that it is available only within the function. This means we will use isEven as a local variable, so it is only visible from within the function, and once the function goes out of scope, the variable would get destroyed. Now let us give this a whirl by doing the invocations in the exact same order that we followed for the impure variant. Let me copy the above logs and paste them down below right here, and this time we are working with the pure even variant function. So let us change this to pure even variant, and let me copy this and change for both the successive logs like this. And now let us understand the results that we get. So here you can see this time we are getting false first, then true, and then false. So these are the correct outputs, right? So for the first invocation of the pure even variant function, we passed a value of 5. So once we make into the function, a variable isEven gets created and gets set to false. We check whether the number is even. If it is even, we change the isEven to true. But this time, we are not mutating something that is present outside the function, but instead we are mutating a variable that is present within the scope of the function, which is this one, right? So here we are mutating the isEven variable, which is wrapped in the closest scope, which is this one, right? So this is the nearest one, right? And not the global one. So we are mutating the local one. Since we are not mutating something that is present outside the function, this is perfectly fine, right? So for the first invocation, this gives us false because we are using the value of 5. 5 is an odd number. Now for the second invocation, we pass a value of 6, and this is a fresh invocation. Here isEven is getting recreated for the second invocation and is set to false first. Then we make into the check. 6 is indeed even. It gets set to true, and then we return that true, which gets logged right here. Now for the third invocation, we again use the same value 5, but this time what happens is that the isEven variable again gets recreated with the value of false to begin with. 5 modulo 2 gives us 1, which is because of which we bypass this check. We return this false, and hence now for the pure even variant function, we get the correct output for 5, which is false. Hence the pure variant of isEven function gives the predictable output here, which is indeed correct. So this was all I wanted to cover about pure functions and side effects. If you liked the video, do give it a thumbs up or comment down below if you have any query. Don't forget to subscribe to the channel, and I will see you guys in the very next one.